Imagine this. You take our entire solar system, the Sun, all 8 planets, every asteroid, comet, and speck of dust, and drop it straight into this thing. It wouldn't even graze the edges. It would simply vanish. No explosion, no dramatic final flash, just gone. According to everything we thought we knew about physics, a monster this size shouldn't exist. It's too massive, too heavy, too impossible. Yet there it is, lurking in the distant cosmos, behind a blinding wall of light, patiently waiting. A gravitational trap so enormous it has crushed the remains of 66 billion suns into a silent, hungry void. Welcome to the terrifying reality of TON 618, the largest known black hole in human history. Today, we're diving deep into the cosmic horror that challenges our understanding of the universe itself. Stick around until the end, because what we discover about this ancient beast might just change how you see our place in the cosmos forever. Let's begin. Most people picture a black hole as a perfect sphere of absolute darkness, cold, silent, and still. For dormant black holes, that image is somewhat accurate. But TON 618 is anything but dormant. It's wide awake and actively feeding. When a supermassive black hole feasts, it doesn't hide in shadow. It screams in light. Picture a swirling vortex millions of miles across, a chaotic storm of gas, dust, and entire shredded stars spiraling downward into a cosmic drain. As this material gets dragged closer, gravity crushes it mercilessly. Friction becomes so intense that the gas heats up to billions of degrees. It doesn't just glow. It ignites into a raging inferno of plasma, outshining everything around it. This blazing ring of fire is called an accretion disk, and when the black hole is this active, now the entire structure lights up as a quasar, one of the brightest objects in the observable universe. A quasar isn't a star. It's more like a cosmic funeral pyre, the blinding death throes of matter being torn apart and devoured. The energy released is so extreme that it can outshine entire galaxies. For decades, astronomers have scanned the night sky for these blazing beacons, using them as lighthouses to probe the farthest reaches of space. In the constellation Canes Venatici, the hunting dogs, astronomers pointed their telescopes and found something that broke the rules. They discovered a quasar shining with the ferocious power of roughly 140 trillion suns. That's not a typo. 140 trillion. The light was so overwhelmingly intense that it completely drowned out the light from the host galaxy surrounding it. Our instruments couldn't even see the stars of that galaxy because the quasar's glare was simply too bright. But the real terror wasn't the light. It was what hid at the exact center of that glare, the engine powering it all, a black hole of unimaginable scale. Compare that to the monster at the heart of our own Milky Way, Sagittarius, a star. It only weighs in at about 4 million solar masses. For a long time, scientists thought that was near the upper limit of what nature could produce. 4 million suns crushed into a single point seemed like the pinnacle of cosmic horror. TON 618 made Sagittarius. A star looked like a speck of dust. Astronomers had to invent an entirely new category, ultramassive black hole. TON 618 doesn't have 4 million solar masses. It has roughly 66 billion solar masses. 66 billion. The event horizon, the point of no return of TON 618 stretches across approximately 390 billion kilometers. To put that in perspective, if you could place the Sun at one edge of the event horizon, light itself would take about 15 days to cross to the other side. Our entire solar system would disappear inside it without a trace. Here's where the story gets truly disturbing. TON 618 sits about 10.4 billion light-years away. When we look at it, we're not seeing it as it exists today. We're seeing it as it was when the universe was still in its cosmic childhood, less than 4 billion years old. Back then, according to our best models of black hole growth, there simply wasn't enough time for a black hole to grow this large through normal processes. Black holes usually start relatively small, from the collapse of massive stars, and grow slowly by accreting gas, swallowing stars, and merging with other black holes over billions of years. Yet TON 618 was already a giant when the universe was young. It's like finding a fully grown adult in a kindergarten classroom. This impossible growth puzzle has haunted astrophysicists for years. How did it get so big so fast? One leading idea is direct collapse. Perhaps in the turbulent early universe, enormous, pristine gas clouds collapsed straight into massive black hole seeds without first forming stars. Another possibility involves rapid mergers in dense proto-galactic environments or even exotic physics we don't fully understand yet, such as interactions with dark matter or unknown early universe conditions. To make this more relatable, let's look at real-world analogies from closer to home. Consider the growth of the largest creatures on Earth. A blue whale starts as a tiny calf and grows to 200 tons by eating vast amounts of krill over decades. Now imagine a whale that somehow reaches 200 tons in just a few months after birth. Biologists would call that biologically impossible without some unknown mechanism. Or think about human cities. Rome wasn't built in a day. It took centuries of gradual expansion, conquest, and infrastructure. But what if archaeologists found evidence of a metropolis the size of modern Tokyo existing just 50 years after the first humans settled the area? That would force us to rewrite history books. Astronomers face a similar crisis with TON 618. It's as if the universe cheated the growth rules we thought were universal. Recent observations of other distant quasars, using powerful instruments like the James Webb Space Telescope, have revealed more of these surprisingly massive early black holes, suggesting that the early cosmos may have been far more efficient at forming giants than we previously believed. Some models now propose super-Eddington accretion phases, where black holes could temporarily eat matter at rates far exceeding what was once considered physically possible. Still, TON 618 remains one of the most extreme examples, a living, or rather devouring contradiction to our timeline of cosmic evolution. For those 10 billion years, while its ancient light was traveling across the expanding universe, the black hole has likely continued feeding. It may have swallowed countless more stars, merged with other black holes, and grown even larger, perhaps significantly larger. We are staring at a ghost, a snapshot from the universe's violent youth, and that raises an unsettling question. If TON 618 was already this monstrous when the cosmos was young, how many even larger beasts are lurking out there right now, in the mature universe, hidden behind their own blinding quasar glows or sitting quietly in the dark after their feeding frenzies ended. The universe doesn't owe us explanations. It doesn't care about our models or our comfort. What fascinates me most about TON 618 isn't just its size. It's what it represents about the limits of human knowledge. We like to think science has tamed the cosmos. We've mapped galaxies, detected gravitational waves, and imaged black holes directly. Thank you, Event Horizon Telescope. Yet here is TON 618, quietly reminding us how much we still don't know. It challenges the standard story of hierarchical structure formation. It forces theorists to consider new pathways for seed black holes in the early universe. Some researchers are even exploring whether primordial black holes or exotic dark sector physics played a bigger role than we assumed. On a philosophical level, TON 618 is humbling in the best possible way. Our planet is a fragile speck. Our sun is one ordinary star among hundreds of billions in the Milky Way. And the Milky Way itself is just one galaxy among trillions. In the face of a 66 billion solar mass black hole, our entire existence feels almost comically insignificant. But that insignificance doesn't have to be depressing. It can be liberating. It reminds us to marvel at the fact that we, tiny conscious beings on a pale blue dot, have managed to detect and understand something so incomprehensibly vast and ancient. We may be small, but our curiosity is boundless. I also find a strange beauty in the violence. The quasar's blinding light is ultimately the death cry of matter, but that same process enriches the surrounding galaxy with heavy elements forged in the extreme conditions. Black holes, for all their destructive power, play a regulatory role in galaxy evolution. They can both stifle and trigger star formation through powerful outflows and jets. TON 618 isn't just a destroyer, and in its own way, it's a sculptor of cosmic structure. So what's the big takeaway from staring into the maw of TON 618? The universe is far stranger, more violent, and more wondrous than we can easily comprehend. And that's exactly why we should keep looking. It teaches humility without despair. Our models will be revised. Our theories will evolve. What seems impossible today may become textbook fact tomorrow because someone refused to accept the limits of current knowledge. TON 618 stands as a cosmic monument to the unknown. It whispers, or rather roars with the light of trillions of suns, that there are still giants out there waiting to be discovered, and mysteries that will keep scientists, dreamers, and curious minds busy for generations. Next time you look up at the night sky, remember, behind the familiar stars and the soft glow of the Milky Way, there are shadows capable of swallowing solar systems whole. And somewhere, perhaps right now, TON 618, or something even larger, continues its silent feast across the eons. We are not the center of the story, but we get to witness it, and that in itself is a profound privilege. Thank you for watching. If this journey into cosmic horror and wonder resonated with you, hit that like button, subscribe for more explorations of the universe's darkest secrets, and let me know in the comments, what other cosmic monsters should we cover next? Until next time, keep looking up, stay curious, and remember how small yet how remarkable we truly are.